Hello friends, in this theory we are going to check for the bias clippers, bias diode clipper circuit. Here I can say this bias diode clipper, that is also known as combinational combination clipper, that is combinational clipper, combination clipper. Now uh, let me draw this circuit. Before drawing this, I'm drawing the input signal. For that, this one is all we know that this one is vertical axis, that is considered for the amplitude. This one is a horizontal axis, considered for the time. I'm going to draw that input waveform. We are considering sinusoidal input only. This is a positive half, one cycle completed, and this one is a negative positive half, second cycle completed. Over here time, this one is the V input, this positive V peak and negative V peak, that is also known as V max positive, V minimum negative. This is 0, this whole cycle, that whole top and bottom amplitude consider is the V peak to peak supply. Now over here combination circuit, that means we are going to use two diode and two bias supply for this one. This is also a Shunt type clipper circuit. In this one, let me draw that. I'm going to apply the input signal this side. This side is our input signal, and that is nothing but sinusoidal voltage AC supply. These two branches I'm going to utilize for the Shunt diode components. This side will check for the V output signals. Now let me draw that particular components. Here resistor, here will be diode, here also one diode. This side will be bias supply. So this one is a resistor. Let me denote R. Now this side is diode. This is diode. One more diode I'm using, that is two diodes. I'll give the names of these diodes. And one bias positive bias, this side is a negative bias. This one is V input, positive, negative. This is V output, this is positive, negative. This is diode D1, over here V1, this diode D2, over here V2. Now we need to check the output for this one. Just drawing that output signal. So this is vertical line for amplitude. V output will draw over here, and this horizontal line for time. And for our understanding, I'm going to use this one for reference lines. Positive half, then negative half, positive half, and negative half. Now as I know that over here this one is a positive bias, this is a negative bias, so we can directly draw these reference two lines, these two reference lines. This one is, suppose that V1 is lesser than V positive peak and V2 is negative bias. Suppose both are equal, but one is positive, one is negative. I'm taking both the references. This one is V1 and this is V2. You see why I am telling that is a negative bias. You see, negative terminal is connected to positive side. This positive terminal connected to negative side. So that is a negative bias. This positive terminal of V1 is connected to positive side and negative terminal of V1 is connected to negative side. That is why V1 is a positive bias. Now we will consider this example and we'll check what will happen to the output side. This one is the V output over here, and this whatever supply we have taken, this positive half and negative half, I'm drawing for the reference only. This one is a positive half, this is for negative bias one. Let me write this V1, this is V2. Now we will check that what will happen to the diode and how that forward and reverse conditions are affecting. And before that, I am also drawing these lines, these points. These are going to be useful when we are drawing the input and output waveforms. Now this point, because at this point only this diode D1 or D2 going to get forward or reverse bias. These are the points, these are the acting points. And from that we can able to draw these output waveforms. So over here, for the positive half cycle, what will happen? You see, when the positive half cycle is there, here will be 0 and over here also 0. You see, diode D1 is already having V1 supply at this N terminal, this is the P terminal. So at that time D1 is how it will act. D1 will be reverse bias, and D2, what will happen to D2? Check. Here is 0 and here is some negative value, so you can directly say that will also reverse bias. So at that point, this whatever input supply is there, it is going to available at the output side. So up to this point, you can directly say up to this point V1 equal to like V input equal to V output. So at this point V output equal to V input. So it is going to get the same value. Now what will happen at one point? At one point this 0 will become V in is equal to at one point V1, or it is trying to get V in is greater than V1. So at that time what will happen? You see, at that time this point is going to get greater than V input is going to get greater than V1. So at that point this D1 is forward bias, because this value Vp is higher now, this is a lesser now. So at that point D1 is going to get forward bias. This is we are considering ideal diode. This is nothing but ideal diode because it is nothing given silicon or germanium. So at that point what will happen if D1 is forward bias? This V1 is directly available at the output side. So what will happen to D2 at the same time? Let me write this one also. D2, check. Here is V1 supply, some positive value over here. This some negative V2 is some negative value. So this D2 is nothing but reverse bias. So no effect of this V2 in the output side. So our V output equal to nothing but V1 at that point. So here this V output is nothing but V1, and that is nothing but a flat value, that is V1. Now at that point once again this condition will appear at this point. At this point when this V input is trying to get below V1, and once again if it is below V1, once again V output will be V input. At this point V output will be V input, and that will happen up to this point, Now what will happen at this point? At one point this V input is lesser than or equal to V2. So now here this one V2 V input is lesser than V2, at that time this diode D2 will going to get in forward bias. So D2 is equal to forward bias, but D1 will be reverse bias. D1 will be reverse bias because that value is lesser. That will no chance of this diode to get turned on. But this one is going to get forward bias because of this condition. So what will happen? Our V output will be equal to V2. At that point, our V output will become V2, and over here once again it will follow the input signal. So likewise, this point, likewise, this this output waveform will become like this way. So positive and negative bias are controlled by V1 and V2. So we can control. You can see this one is plus Vp and this is minus Vp. But this waveform, this actual output waveform is clipped from this section only. Positive part is also clipped and negative part is also clipped. So that is a combination of clipping. And this V1 and V2 can be controlled by ourselves. So this is a combination clipper, or you can say this is nothing but positive or negative bias, fully biased circuit. You can also say that is a fully biased circuit or clipper. So this kind of circuit over here you can take any reference voltage, but actually if you take Vp equal to 15 plus 15 and this is minus 15, at that time you consider this one is a 5 volt, this is a minus 5 volt. So this one is a 5 volt, this is a minus 5 volt. At that time this signal you can get this type of flat signal over here, and this is a both the side it is clipped. So I hope you understood this combination clipper circuit, and you understand the concept of positive bias and negative bias circuit. We have already discussed this positive bias circuit, but this part is a negative bias one. So over there negative bias, negative clipping is there, negative portion of the waveform is clipped. So this is a negative bias part. So this is how, if suppose this branch is not given, this only branch is given, at that time the effect of this minus phi is there. So you need to consider each and every time that V input, what will happen to the diode. If diode is short circuited, the direct supply available over it will be output side. If the diode is open circuited, whatever input is there will get at the output side. That is what you need to remember. Whichever diode is working, there is no any situation where both the diode is in forward bias. It is not possible in this circuit. So at a time only one diode is in forward bias. So whatever diode is in forward bias, that bias supply will be available at the output side. So one by one, if you check each and every diode, you will come to know which diode is forward bias and which diode is reverse bias. And if both are reverse bias, you directly say that whatever input signal is there, it is available at the output side. So I hope you understand this combination clipper circuit. Thank you.